Good morning to all. Myself, Dr.R.REKA, Assistant Professor, Department of Statistics, Sri Sharda College for Women, Salem. In this video, I am going to explain LPP using Simplex method. The Simplex method, it is nothing but it is a systematic procedure for testing the vertices as possible solutions. Since there are many algorithmic methods to solve linear problem. Here, I am going to explain LPP by using Simplex method. See the problem. Solve the following LPP by Simplex method. So this is the maximization problem. Maximize Z is equal to 15x1 plus 6x2 plus 9x3 plus 2x4 and subject to the constraints. The first constraint is 2x1 plus x2 plus 5x3 plus 6x4 less than or equal to 20. And the second constraint is 3x1 plus x2 plus 3x3 plus 25x4 less than or equal to 24. And the third constraint 7x1 plus x4 which is less than or equal to 70. x1, x2, x3 and x4 which is greater than or equal to 0. So this problem is a maximization problem. The problem is converted to canonical form by adding slack, surplus and artificial variable as appropriate. So here as the first constraint is of type less than or equal to. So we should add slack variable s1 and as the second constraint 2 is of type less than or equal to. So we should add slack variable s2 and the third constraint is of type less than or equal to. So we should add slack variable s3. The objective function is maximize z is equal to 15x1 6x2 plus 9x3 plus 2x4. So when three constraints are given, see while you write three constraints, you will need to add slack variables along with this. The first constraint, we add first slack variable s1, that is 2x1 plus x2 plus 5x3 plus 6x4 plus s1 which is equal to 20. The second constraint adds second slack variable, that is s2. The second constraint is 3x1 plus x2 plus 3x3 plus 25x4 plus s2 which is equal to 24. And the third constraint, add a third slack variable s3. That is the third constraint is 7x1 plus x4 plus s3 equal to 70. For each constraint, add one slack variable in order to balance the constraints. Hence, we have added three slack variables. So, we need to add the slack variable in the objective function. So, maximize z is equal to 15x1 plus 6x2 plus 9x3 plus 2x4 plus 0x1 plus 0x2 plus 0x3. The first slack variable is 0 and the same way the second slack variable is 0. Then the third slack variable, the value is 0. So here this one is first constraint and this one is second constraint and this one is third constraint. So x1, x2, x3, x4, s1, s2 and s3 which is greater than or equal to 0. Now let us see how I am going to frame the initial simplex table. See here in this table Cj. So just Cj row denotes the coefficient of the variables in the objective function and Cb column denotes the coefficients of the basic variable in the objective function and Yb column denotes the basic variables and Xb column denotes the values of the basic variables. Then the coefficients of non-basic variables in the constraint equations constitute the body matrix, while the coefficient of the basic variables constitute the unit matrix. Then the row Zj minus Cj denotes the net evaluations. Here Cj, the value is 15. The variable is x1 and Cj value is 6. The variable is x2. Then Cj value is 9. The variable is x3. And Cj value is 2. The variable is x4. And Cj value is 0. The variable is x1. And Cj value is 0 and the variable is x2. And Cj value is 0. The variable is s3. In CD column, we need to add coefficient value of basic variables, that is s1, s2 and s3. And also we need to add slack variables s1, s2 and s3. These are three basic variables. Then xb denotes the value of the basic variables, that is 20, 24 and 70. Then we need to add the coefficient of constraints. The first constraint is 2x1 plus x2 plus 5x3 plus 6x4 plus s1 plus 0s2 plus 0s3, which is equal to 20. So we put the coefficient value in initial simplex table. That is 2, 1, 5, 6, 1, 0, 0. And the same way, we need to add the coefficient of second constraints, that is 3, 1, 3, 25, 0, 1, 0. And the same way, we add the coefficient of third constraint in the initial simplex table. The coefficient is 7, 0, 0, 1, 0, 0, 1. So here we create the initial simplex table. Then we have to find the Zj minus Cj. So the formula for Zj minus Cj is sum of Cb into Xij. So here just we multiply Cb into x1 minus Cj value, that is 0 into 2 plus 0 into 3 plus 0 into 7 minus 15. So the value is minus 15. So next column 0 into 1 plus 0 into 1 plus 0 into 0 minus 6. So we put minus 6. So then next column 0 into 5 plus 0 into 3 plus 0 into 0 minus 9. So the answer is minus 9. So next column, just to multiply 0 into 6 plus 0 into 25 plus 0 into 1 minus 2. So we get minus 2. So next one 0 into 1 plus 0 into 0 plus 0 into 0 minus 0. So the answer is 0. So next one 0 into 0 plus 0 into 1 plus 0 into 0 minus 0, which is equal to 0. So next one 0 into 0, 0 into 0, 0 into 1 minus 0, so which is equal to 0. So then we have to take minimum value of Zj minus Cj. So here minimum value is minus 15. So we take x1 column. After that, we find the ratio, minimum ratio, that is theta, which is equal to xb divided by x1. Here, in first row, that is xb divided by x1, so xb value is 20, so 20 divided by x1 value is 2, so 20 divided by 2, which is equal to 10. And the second row, 24 divided by 3, which is equal to 8, and third row 70 by 70, which is equal to 10. So here we have to take the minimum value is 8. So here entering value entering variable is x1 and leaving variable is s2. So because so zj minus cj, which is less than 0, so here the current basic feasible solution is not optimal. So the non-basic variable x1 enters into the basis and the basic variable s2 leaves the basis. So next one, we go to the first iteration. Next one, I am going to frame first iteration. So here x1 enters into the basis and s2 leaves the basis. In a previous slide, we have some formula for find out the new rows. R1 new, which is equal to R1 old minus 2 R2 new. Second one, R2 new equal to R2 old divided by 3, and third one, R3 new is equal to R3 old minus 7 R2 new. So this is the formula for find out new rows in first iteration. So in first iteration, here YB is S1, X1 and S3, and coefficients of these variables are 0, 15 and 0, so which is in CB column, and XB values are 4, 8 and 14. So here we have to find out the ZJ minus CJ values, that is 0 into 4 plus 15 into 8 plus 0 into 4 minus 0, so which is equal to 120, so we put 120 here. And next one, 0 into 0 plus 15 into 1 plus 0 into 0 minus 15, which is equal to 0. So and next one, 0 into 1 by 3 plus 15 into 1 by 3 minus 0 into 7 by 3 minus 6, we get minus 1. Next one, 0 into 3 plus 15 into 1 minus 0 into 7 minus 9, which is equal to 6. Next one, 0 into minus 32 by 3 plus 15 into 25 by 3 plus 0 into minus 172 divided by 3 minus 2, which is equal to 123. So next one, 0 into 1 plus 15 into 0 plus 0 into 0 minus 0, which is equal to 0. And next one, 0 into minus 2 by 3 plus 15 into 1 by 3 plus 0 into minus 7 by 3 minus 0, which is equal to 5. And next one, 0 into 0 plus 15 into 0 plus 0 into 1 minus 0, which is equal to 0. So now we get Zj minus Cj values. Here minus 1, which is the minimum value in Zj minus Cj. Then we have to find out the minimum ratio theta. So here Zj minus Cj, which is less than 0. So then we have to find out the theta. So theta, which is equal to xb divided by x2. So that is 4 divided by 1 by 3, which is equal to 12, and 8 divided by 1 by 3, which is equal to 24, and 14 divided by minus 7 by 3. So we get a negative value. Just we terminate this. So here the minimum value is 20. So the first row, this is key row, and this column, that is x2 column, is key column. So here s1 is the leaving variable, and x2 is the entering variable. That is here zj minus cj, which is less than 0. So the current basic feasible solution is not optimal. So next we go to the second iteration. That is the non-basic variable x2 enters into the basis, and the basic variable s1 leaves the basis. So next one, we frame the second iteration. So here we use this formula for finding the new rows. So r1 new is equal to 3 r1 into old, and r2 new is equal to r2 old minus r1 old, and r3 new is equal to 7 r1 old plus r3 old. So this is the formula for find out the values in second iteration. So here we have to frame the second iteration table. So here yb. So here x2 enters into the basis, and x1 and x3 variables. Next one, cb column, that is the coefficients of these variables. That is the coefficient of x2 is 6, and the coefficient of x1 value is 15, and the coefficient of x3 value is 0. So next one, the value of this variable is 12, 4 and 42. So next one, we have to find out the Zj minus Cj values. So 6 into 12 plus 15 into 4 plus 0 into 42 minus 0. So which is equal to 132. So next one, 6 into 0 plus 15 into 1 plus 0 into 0 minus 15. So which is equal to 0. Next one, 6 into 1 plus 15 into 0 plus 0 into 0 minus 6. So which is equal to 0. And next one, 6 into 9 plus 15 into minus 2 plus 0 into 14 minus 9, which is equal to 15. And the next one, 6 into minus 32 plus 15 into 57 by 3 plus 0 into minus 132 minus 2. So which is equal to 91. Next one, 6 into 3 plus 15 into minus 1 plus 0 into 7 minus 0, which is equal to 3. And next one, 6 into minus 2 plus 15 into 1 plus 0 into minus 7 minus 0, which is equal to 3. And next one, 6 into 0 plus 15 into 0 plus 0 into 1 minus 0, which is equal to 0. So here Zj minus Cj, which is greater than or equal to 0. So here there is no negative values are there. Since all the Zj minus Cj values are greater than or equal to 0. So the current basic feasible solution is optimal. Therefore, the optimal solution of given problem is maximize Z is equal to, that's the value of maximum of z is equal to 132, and the value of e, the value of the variable x1 which is equal to 4, and the value of x2 is equal to 12, and the value of the variable x3 and x4 is 0. So this is the simplex method problem. So this is my reference book. Thank you.